So hello everyone. In this lecture, in this series of piezoelectric material, we will solve problem number 4.9 of the book Engineering Analysis of Smart Material and Systems. In this problem, what is given? A piezoelectric material operating in the 3-3 mode has the material property. These are the material property. Piezoelectric strain coefficient is given, which is 450 picometer per volt, and Young's modulus, which is 63 GPa, is given. So these piezoelectric strain coefficients and Young's modulus is given, and we have to compute the block stress. Block stress means the stress when the force is zero, and the free strain means when the strain is zero under the application of the electric field. This is the electric field, and we will also compute the voltage required to achieve the block stress or the free displacement for a vapor that is has the 250 micron thickness. So we have to compute the block stress and free displacement under electric field, right? So D is given, which is 450 picometer per volt, and Y3E is given, which is 63 GPa. So we have to compute the block force, that is stress, that is T3 when U3 is equal to 0, and uh, or S3 is equal to 0, and S3 when T3 is equal to 0, right? So we have to compute these two quantities, right? So we know the relationship between the uh, T and S from the first video, from our first video. Like we have one dimension 1D consecutive equation, which is strain is equal to strain in the direction of 3 stays in the direction of 3. This is 1 by S, which is equal to the Young's modulus plus D33 E3. This is the one dimension piezoelectric equation. It's come from the three dimension analysis of the composites, sorry, of the piezoelectric materials, right? So the question is, we have to compute the block stress and the free strain. So for the free strain, what we can do, or for free strain, T3 is equal to 0. So free strain means when T3 is equal to 0, means no force on piezoelectric materials. So we are not applying any force on the piezoelectric material. Piezoelectric material is the free. Like this is the piezoelectric material. Suppose this is connected. This is wire. This is switch. So this is connected. So we are not applying any force here and here. This is free. So this is called the free stress condition when T3 is equal to 0. This is the free strain. This is open. It get enlarged in this and this direction. So it's free, completely free. So T3 is equal to 0. So S3 when T3 is equal to 0, that is the free strain D33 E3. D33 is given, which is 450 picometer, means 10 to the power minus 30 meter per volt. Electric field is given, which is equal to the 0.75 m volt per meter. So it get cancelled, and this 10 to power 6, because it's uh, megavolt, so it's 10 to the power 6. This is picovolt, so 10 to the power minus 12. And when you solve this, you will get 337.5 10 to the power 6 or 337.5 microstrain. So this is our part 1, in which we have to compute the free strain and the block force, block stress and the free strain. So this is the free strain. For the block force, for the block stress is T3 when U3 is equal to 0, right? So or S3 is equal to 0. U3 means displacement is 0 or the uh, strain is 0. So when you put here 0, uh, this will remain, and this will 0. Then T3 is equal to minus D33 E3. Why E3? But it's comparison, so we are not taking the sign, so it's T3 S3 equal to 0, which is the block force, block stress. This is the block stress, which is equal to D33 E3, uh, piezoelectric strain coefficients in third direction, 3 direction, electric field in third direction, and multiply by the Y3E, uh, Young's modulus in third direction. So D33 is 450, 10 to the power minus 12. E3 is 0.75 multiplied 10 to the power 6, and E3 is given, which is equal to 60 into 9. So it comes out 2126.2.5 minus 12 plus 6, 10 to the power 3. This is Pascal, or for Newton per meter square. Stress, the unit of stress is Newton per meter square. So this is the block stress T3 when U3 is S3 or U3 is 0, when the displacement is 0 or uh, strain is 0. So if you clump this material, then S3 will be 0, because it's not get enlarged. If you clump this material by some mean and apply electric field in 3 direction, that is the thickness direction, so not get enlarged, so S3 will be 0, and by the S3 this formula will be comes out, and by plugging these values, this result will be comes out of block stress and free strain. Now let's move to the part 2. Part 2 is the compute the voltage. We have to compute the voltage required to achieve this block stress, means block stress in the part A, or free displacement in the part A vapor, that is the has the 250 micron in thickness. So thickness is given, right? T is given. So So we have electric field E3 is 0.75 mega volt per meter, and thickness TP is 250 multiplied by 10 to the power minus 6 meter, right? Then we have electric field. These two quantities are given. Electric field is given in the 3 direction, and the thickness is given, right? Because we are applying the uh, electric field in the 3 direction, that's why this is called the 3-3 mode, right? We are working in the 3-3 mode. So we know that the electric field is equal to the voltage multiplied by the thickness. This formula, if you don't remember, please go, uh, I think class 11th or 12th, this of chapter voltage and electric field, you will easily found this formula there. So we have to compute voltage multiplied by E3 V3 multiplied by TB thickness. So E3 75 10 to the power 6 volt per meter multiplied by 250 10 to minus 6 volt. This will cancel out, so this will remain 0.60. This will also cancel out because minus 6 plus 6 is 0, so 250 volt. So 0.75 250, which comes out to be 187.5 volt, right? V3, this is our volt. uh, if this is our volt to achieve the block force or the free strain of part 1, this much voltage of required, right? So this is the complete question 4.6, in which like uh, piezoelectric strain coefficients Young's modulus is given, electric field is given, and block force and block stress we have to calculate. Thank you.